During this video, you'll find out how to construct experts distributions based on the three elicited quantiles. The distribution of a random variable can be described by using the cumulative distribution function or the probability density function. Recall that the p% quantile of the distribution of a continuous random variable x is the value a of x, such that the probability that x is smaller than a is p over 100. Quantiles are easy to find graphically from inspecting the cumulative distribution function, or CDF. Let's look at the CDF for an exponentially distributed random variable with parameter 1. The plot can be used to compute the probability that x is smaller than given positive values. For example, for a equal 2, the probability that x is smaller than or equal to 2 is 1 minus e to the power minus 2, which is 0.86. Now, say we are interested in finding a such that the probability that x is smaller or equal than a is 0.5. Recall that a is called the median. We will see now how we can find its value graphically. That is, we start on the y-axis at 0.5. Then, draw a parallel line with the x-axis until we intersect the graph of the CDF. Afterwards, we draw a parallel line with the y-axis until it intersects the x-axis. The corresponding x value is 0.6931. This is the 50% quantile. Similarly, we obtain the 5% quantile in the same graphical manner and find it to be 0.512. In the same way, the 95% quantile is found to be 2.9957. So once we have the CDF, we can compute any quantile we want. We saw how the quantiles can be computed graphically. In practice, quantiles of distribution functions are readily available in any data analysis software tool. But let's go back to our graphical example. We will find out now how to construct the CDF, but also the PDF, that is the probability density function, when we start from the three elicited quantiles. Let's see. Suppose we ask an expert about the percentage of women CEOs among the largest publicly listed companies in the European Union in 2019. The expert provides a best estimate of 15, and he or she is 90% confident that the true percentage is between 5 and 30. We model the quantity of interest as a continuous random variable and construct its CDF by first plotting the 3 points corresponding to the quantiles. That is, 5 corresponds to 0.05, 15 corresponds to 0.5, and 30 corresponds to 0.95. The question is about percentages, so we know that the random variable can take values from 0 to 100%. We say that the support of the distribution is 0, 100. You will learn later on how to determine the support of random variables based on the assessed quantiles and the true value. So, we can plot now 2 other points, that is 0, 0, since the probability that the percentage is smaller than 0 is actually 0. And since the probability that the percentage is smaller than 100 is 1, we have the point 101. From these 5 points, we can construct now the CDF, simply by interpolating. We now have the expert's cumulative distribution function. The interpolation is quite straightforward, but brings an important assumption. This becomes quite clear when we look at the probability density function, or the PDF, rather than at the CDF. Recall that the PDF integrates to 1. So, if we integrate the expert's PDF over 0, 100, we should obtain 1. Plotting the expert's PDF results from how the mass is distributed. We draw the 5 points on the support of x. The 5% quantile means that the expert believes there is a 5% chance that the percentage of women CEOs in EU is below 5. So 0.05 mass is placed in the interval from 0 to 5. Given the assessments for the 5% and 50% quantiles, 0.45 mass is placed between 5 and 15. In the same way, 0.45 mass is between 15 and 30. Finally, there is 0.05 mass between 30 and 100. How is the mass distributed within the 4 intervals? Within the classical model, a minimum information distribution is assumed. That is, a distribution which adds as little information as possible to experts' percentile assessments, relative to the uniform measure. That basically means that the mass is distributed evenly within the 4 intervals. The density will be then equal to 0.00833 in the first interval, 0.045 in the second interval, 0.03 in the third interval, and 0.000714 in the fourth interval. This is obtained by dividing the corresponding mass to the length of each interval. Also, note that the PDF is 0 outside the support. Here is a scatter chart, and here you can see the line chart, which is typically displayed for PDFs. So we have seen how to construct expert distributions from the 3 elicited quantiles. The distributions will be very important for the aggregation of expert assessments and for answering the questions of interest. Finally, you might wonder, what is the actual percentage of women CEO in the largest listed companies in EU? Well, this is 6.9%. And notice that the true value is within experts' 90% credible interval. You can find the reference here. Thank you for your attention.